Okay, a linked list. So we've talked about arrays. Y'all probably used a linked list. A linked list is going to be the first structure where we start talking about a pointer structure, aka we have a node that contains data and pointers that point to something else. A lot of your data structures from here on out are going to be this idea of you having some central node pointing to something else. The linked list is going to be the most simple, or the simplest, of this type of structure. Beforehand we've done arrays, which is just a contiguous block of elements. Now we're going to have a data structure that can dynamically increase and decrease as needed. That's nice. That's also nice. Great. Okay, good. Thanks, slides. All right, first off, a linked list is a collection of items, nodes containing two components, the data and the link. Hey, what's the link? What have I been calling it the whole time?
The next data.
The what?
Next piece of data.
Next piece of data. Oh, but if it's a link, what is it?
Oh, it's a pointer.
It's a pointer. All right, the link is a pointer. It's a pointer. So it contains a piece of data and a pointer. What do you think it points to?
The next one.
The next one. All right. Whew, we're doing great. All right, so they're not going to show the memory address. They're just going to say, here you go. We have a head. Hey, what's head?
The first pointer.
Someone said it.
First pointer.
It's the first pointer or the beginning. So head is a pointer. Nothing else. It's just a pointer. And we're going to call each of these a node. So it points to the first node, 45, which then points to the next node, 65, which points to the 35, which points to the 76. Do these need to reside next to each other in memory?
No.
No. Do they need to be, their location in memory need to be ascending? Like 45 is in the first part, 65 in the next part, 34 in the next, and 76 it can be spaced? No. They can jump all around. It doesn't matter. Good. Let's just go to code. Because really, why would we do something else? Ew. Linked list. I don't know why I did that. All right. Nope, don't do it. Don't do it. Don't do it. What was in source in this one, by the way? Oh, we had fun. All right. Let's change that up. All right. I'm just going to call it sll.hpp, singly linked list. We'll get to that in a moment. All right. So the first thing we want to do is we want to define what this node is, because that's the basic component of the linked list. So I'm going to type it all out. I'm going to call it the S linked list node, because I don't want to type all that out. Ooh, it's doing some funny tabbing. Let's redo this. Perfect. Okay. What's inside of this linked list node?
I guess an integer and pointer.
All right, so let's do the integer first.
45.
Y'all got this. I know y'all are connected.
Oh.
There. Data val. And then, what else is there? So we got the data, and then we have
Pointer.
a pointer. What's it pointing to?
The next data val.
All right. Let's see. Oh. Well, I can see how from the picture it looks like that's what's happening, but it's really pointing to an entire new node. So it's not just to an integer. What it's actually pointing to is a node. All right. think about this, because sometimes students get a little confused. I have a class, it's a node, has data, and then it has a pointer that points to another one of itself. Is this going to compile? Yeah, this will compile because it's a pointer. We're just storing a pointer. What would not compile is that. Why would that not compile?
It's creating a lot of nexts.
Well, it tries to create the first one, but it contains itself, so it goes ahead and tries to instantiate itself inside of itself, so now it's got to do that again, because that second time it's defined on itself again, and it just keeps going ad infinitum. But if you just say a pointer, then you're like, oh, okay, we're just storing a pointer. Well, that's good. So we can either make this really OOP, or we can just say, OOP, we're tired of you. So the OOP, we're tired of you way is to make it public, and we can just access the values. Right? The proper OOP is to make these private and then create functions that automatically, get and set them for you. All right, what you want to do?
Honestly, leaving them as public seems good to me.
Alrighty then. Okay. So we'll create the class singly linked list. This one, at least, let's do it proper OOP. What does a singly linked list contain?
A
head. All right, go do it. Oh, go ahead. Ooh. H times E add. Yeah, all right, pointer. That makes sense. Perfect. Let's go help ourselves out just a little bit more. And we're going to say, OOP, we are really tired of you. You should really never write your code inside of a header file. That's all. And what's also funny is I did that. There we go. That way we can at least automatically create it. All right, so that's the private part. What do we want inside of this? Well, we want to be able to create the thing, right? Okay. What else do we want to do?
Add.
Yeah. All right. We'll add something to it, get the size, ask if it contains a certain value, maybe remove.
Yeah.
This should actually be a bool because it's C++, and then bool remove. Okay. Hey. Well, let's okay, let's go inside of main. Actually, we don't need to be doing this anymore. Squirtle.
Poor Squirtle.
Poor Squirtle. All right, good. It compiled. Ship it. All right. Right? If it compiles, that means it works perfectly. Okay. Over here, let's do make. Sounds great. Nothing to be done. And let's go take this code. Oops. Y4 down. Let's go to the header file. Oh yeah, this. day I'll put in the plugin that does this for me automatically. All right. Well, that looks amusing. Let's see if it actually compiles. It does. Great. Okay. Let's see. All the way over here. Oh, we got these old tests. Let's get rid of those tests. Let's make something better. We'll go ahead and include sl.h. Actually, what did I call it? I don't remember. Tell me quick. It's all lowercase. HPP. All right. So we want to be able to create a singly linked list. Want to be able to add a number, maybe 1, 2, 3, 4, and then we want to test. Wow, I already forgot the commands. Let's find out. There we go. That should be true. Good morning.
Hey.
You made it. Traffic?
No, he's a.
Yeah, let's say that.
Let's. Originally, I had a rule that if you're more than 20 minutes late, you have to give me a good story. I didn't say it had to be true. You just have to give me a story.
Well, I was in bed.
It has to be a good story. It's already starting terribly.
It was one of those, like, I woke up to my alarm at 7, and then I just, like,
And then you realized the Earth was about ready to end,
yeah.
so you called up Optimus Prime.
I might be getting mixed up with dreams now.
All right.
Got gas prices going to drop.
All right, well, next time, just work on a good story, okay? Make sure it's like 5 sentences max. We don't want it to be long.
5-sentence story, huh?
Yeah, 5-sentence story. All right, where was I? Oh, okay. So we add it, and then we need to find out that it contains it. Okay, great. So if we delete the rest of this, jump over here, make simple test, make sure we fail. It passes. Oh, probably because contains always returns true. Well, we could fix that. And it should not contain 1, 2, 3, 3. There we go. Yeah, that's interesting. I wonder why we're passing. I didn't write the code, did I?
Contains. Thanks.
Oh no.
How did it compile that?
Okay, fine.
Statement?
Anyways, know what that's about. Let's go fix the test case where we can add 1, 2, 3, 4 and then ask if it's in there or not, and then it actually returns true or false. So the constructor. What should the constructor do by default?
Just create a head.
Well, we definitely want to do something with head. But if this linked list had no items in it, what would head point to? Or let me rephrase that. What should head point to?
No.
Null. All right, let's set head to null. You got this. All caps. All caps, null. Yeah. All right. That was good. Let's see if that compiles. All right, let's go ahead and include stdlib. Ooh, getting some latency there. All right. All right, now we want to add something to it. How do we add? We want to add, what's the first thing we want? Actually, the slides go through this? Not yet, because it tries to make things confusing first. If head's pointing to null, what's the first thing we need to do?
Change head.
Yep.
Change it to what?
A node.
A node. Well, but do we have a node?
No.
No, so we can't do that yet.
Yeah.
Should
Create a
you should
node.
We need to create a node. Let's create a node. I like that. Somebody create a node. SLL node star to add. All right, I got this. I'll get you started on this one.
Like, it's purely because I'm trying to remember the values.
Well, what are the values? Oh, okay, I see. Well, here's the header for the constructor. Oh, are y'all used to like the drop-down thing and it says, oh, we're going to put it in this value here? I forgot about that, yeah. Voila. And what is next going to be? Ooh.
No.
Okay, we'll start with null. That's good. I like that. All right. Sorry, I was saving that. Let's just make sure that compiles. Good. We're still in the good sync. So we've created the node. Now what do we do?
I guess insert it to the end.
Okay, perfect. All right. This is a great starting point. It is not correct yet, but it is going to work for many cases. So let's stick with this for now. All right. So next we need to ask if it contains this value. Well, what can we do? Let's write the minimum amount of code necessary to pass the test case. What's the test case? We add a value, and then we ask if it contains it. So the only SLL node you have right now is head. So we need to be working with head. And head's a pointer. Yeah, what'd y'all call it? Hold on one second. Let me drive.
It is.
Data val. There we go.
Capital D.
He's going to continue on anyways. All right, let's go uppercase that V.
Oh, sorry about that.
We were getting really excited. All right. Okay. Let's see if that passes the test case. Ooh. All right, there we go. It passes. All right, so we passed simple. Beautiful. All right, I'm going to leave that alone because we finally passed it. Wow, I'm having some serious latency issues here. Let's create an empty linked list and just see if it contains, it can fail on that. Ooh, segmentation fault. Huh. All right, well, let's see if Valgrind can help us out. All right. Process terminating with default action of sig 11.6sev, not address not within mapped region of address 0, aka you are trying to dereference a pointer to null. Happening on SL contains int on line 20. It's happening, hey, line 20. It's happening right here. Well, there's only one pointer, and that's head. So what's the problem?
Head is currently null at that point.
Right, so if you try and dereference null, you shouldn't do that. Alright, how can we fix that? Oh, I like this. Excellent. All right, let's see if that fixes that error. No, good. We pass void. I should really call this something besides simple test. Let me get out of here. Good. Now it's just SLL test. All right, well, we fixed that error. And let's see, what other fun errors can it give you? Multi-add. One, 2, 3, 4, 1, 2, 3, and 1, 2, 3, 4, 5. It's the password on my luggage. Actually, we'll leave that there. Okay, so if we add 1, 2, 3, 4, and then 1, 2, 3, 4, 5, we should be able to return true that both of those things exist, and of course return false that 1, 2, 3, 3 is not in there, or return false because it's not in there. All right, let's see what happens. Ah, fail. Line 31. Line 31. So it can't even find 1, 2, 3, 4. What's going on? There's multiple things going on.
That is pointing to the second SSL node or SL node that you made.
Sure. Okay. There's a problem with both contains and add. What happens the second time we try and add something? Well, let's go look at it. And sorry, people at home, you're not going to be able to watch this. So we have head. Null. First thing we do, I don't, because I need to find an eraser. Perfect. First thing we do, so that's this line. Now we're going to add 1, 2, 3, 4. All right. What does that do? Well, let's look at the code. We'll start here. So let me keep it null right there. We're going to create a node that contains 1, 2, 3, 4, and then a pointer over to null. Right? That's what the code does. Then we're going to set head equal to 2 add, so we're going to take that and just go right here. Oh, that looks good. That's great. Now we're going to add 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. And first thing, 1, 2, 3, 4, 5, and it points to null. Okay. What does the next line of code do?
Changes the head value to that.
To the new node. But that new node points to null. what should it be pointing to?
It should point to the existing node of the.
Yeah, to the previous value, right? We should have had this link go up here. So let's go back one line of code, right up here. And let me draw this out a little more. We have head pointing there. We have to add pointing to that new node. What do we need to do before we set head equal to the to node?
We should have it be that the first node points to the second.
Okay, so we want this pointer to point to this guy. How can we do that? I'll put you in insert.
Set the next node to the previous one.
Yeah, yes. We need to set two adds next equal to this node. How do we do that? Instead of setting it to null, what should we set it to?
1, 2, 3, 4.
No. Remember, null is a pointer. You set to 1, 2, 3, 4, that's the memory location 1, 2, 3, 4. Right? Because it's a pointer. What should this...
The node of 1, 2, 3.
The node of 1, 2, 3, 4. Do we have anything pointing to that?
Yes.
We have head. So instead of putting null, we should have
Head.
right. So instead of null, someone type it for me. All right. You see, you draw it out, took more time to figure out what needed to be typed than to actually type it. That is very important. Volume of code does not make it better. A lot of times less code makes it way, way better. I'm to the point where nothing makes me happier than being able to delete 5,000 lines of code I wrote a year ago because it's no longer needed. Because I can now do it in 100 lines. There. That solves that problem. Because now, one thing very important is since we've changed the code, we need to reevaluate the entire operation because from the beginning, because it may have changed something else. So let's go back and watch it from the beginning. So this is initially pointing to null. Perfect. And now we're going to create a node of 1, 2, 3, 4. And 1, 2, 3, 4, its next value is going to be head. But what's head right now? Null. Okay. Oh, well that's good. That's convenient. And then we'll have it equal to 2 add. Perfect. Now we're going to do the same thing with 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But now the next is head. So it's going to copy that pointer over here, and it's going to point to the same thing as head. And then, whoops, let's jump to the code. Goes to the same thing as head. And now we're going to update head to be to add, which is that new node down here. That looks correct. Looks correct to you? Good. All right. Okay. But of course, we're not done yet. Still failed in the same spot. Because what's the problem down here?
Only tries the first value.
We're only trying the first value. All right. I think the slides actually talk about this a little, so let's jump over to it. That's nice. So some properties, they like to use the word current. I like to use the word rover. But you create another pointer that can start somewhere and can move along the list. Wow, it's just going to show you that. Okay, I'm going to write this for you because I think it's easier if you see the solution in this case than it dawns on you, because you're going to have to apply this solution to numerous other locations. So it's not like I'm just giving it to you. And I'm going to explain how I think about this. And also, it is very important to code a certain way. Certain ways I do believe are better coding practices than others. There are certain coding practices I will say, it's a trade-off how you want to do it. But one thing I believe very strongly in is what's called a guard clause. In other words, if head equals null, return false. Okay, why do I want to do that first? Because by putting the guard clause there, I now can guarantee that head after that line of code is valid. And I don't have to constantly check or start doing some nested if statements or whatnot. It has to be valid. I don't have to worry about it, don't have to think about it. Head is now valid, which means we can get rid of this part. Okay.
Nice.
Yeah. All right. Also, yeah, we're good there. Now, I'm going to just write the code. SLL. I'm going to create a node called rover that's going to start at head. So rover, I'm allocating another pointer on the stack called rover. Its type is a pointer to an SLL node, and I'm setting it equal to head. All right. I'm going to run this for loop for as long as rover is valid. At the end of the for loop, the iterator is not rover plus plus, because that would be incrementing the pointer by one node unit. That doesn't make sense because they reside at different locations in memory. So to get to the next item, I literally do rover equals rover next. All right, before I continue, let me explain what this for loop's doing on the board. We have the simple linked list. We're going to create another pointer called rover. It's a pointer, and we have it initially setting equal to head, so it's going to point right here. Okay? First thing we do is we check rover. Oh, in case this is not clear, this is the same check as does not equal null. Because in C and C++, any non-zero value is true. So 1 is true, a memory location that's not null is true, a negative value is true. Only 0 is false. So by just typing in the value, it evaluates to true as long as it's a valid pointer, or AK, not null. So we check, is rover pointing to null? Nope. So then we're going to go inside the if loop, for loop. I'm not doing anything in the for loop right now because we haven't gotten to that yet. But at the end of this for loop iteration, we're going to have rover equals rover dash next. So rover is going to equal rover dash next, which is up here. You like that? All right. Now we do the same check. Is rover null? No, it's pointing to a node. Going to do some code, not going to get to it yet. And then we're going to have rover equal to rover dash next. Well, rover dash next is null. That's fine. So we'll have rover equal to rover dash next, which is null. Then we go do the check rover. Well, rover is now null, which means that it'll exit the for loop and then return false. All right. Any questions on that? The STL version of this is actually way more complicated. All right. So I have Rover, and it's going to iterate to every single node inside the linked list. We want to find out if a value is contained inside the linked list. All right. You got this. Do it. If data val perfect. Thank you. It passed. Basically, we just check every rover to see if the value is equal to that. Okay. Hopefully that wasn't too bad. All right, here we go. Now let's pause for a moment.